graph y is equal to 3 to the power of x, and y is equal to log of x to the base 3. So let's take a look at the first one. Graphing y is equal to 3 to the power of x. You're going to let x equal to 0. If x equal to 0, what is y? Anybody who following this, somebody says 1. So it would be 3 to the power of 0. Anything to the power of 0 is equal to 1. That's correct. So our graph is going to pass us through this point here. So let's locate this point right now. If x is equal to 0, y is equal to 1. So my graph has to pass us through this point here. X equal to 0, y is equal to 1. So let's take a few more points here. As I increase x, if x is equal to 1, what is y? It would be 3 to the power of 1, which is equal to 3. Very good. So if x is equal to 1, y is equal to 3. And as you see, as I increase x, this graph going to exponentially increases sharply this way, right? So that would be a rough graph of this, looking at it that from that side. So we just find 3 points here to confirm that. So this would be 1 and 3. And also we find the y-intercept so far. So let's take another point to the left of 0. So if x equal to -1, what is y? That would be 3 to the power of -1, which is equal to 1/3. So as you see, as I increase x, this graph gonna go up. As I decrease x, this graph gonna get closer and closer to 0. So 1/3 would be right somewhere around here. You get really close to 0 here. So the graph gonna go from the other end this way. So that would be a rough graph of this exponential y is equal to 3 to the power of x. Let's take a look at the next one. Y is equal to log of x to the base 3. One way to graph this, you can't convert this to a corresponding exponential. You remember how to do that? If I have log of x is equal to y with the base b, can somebody here tell me how do you convert this to a corresponding exponential function? We talked about this in a previous session. That would be b to the power of what? Do you remember that? Y is equal to x. So you really need to know this relationship. So if we're going to convert this y is equal to log of x to the base 3 to its corresponding exponential, I would have to write it as 3, that's my base, to the power of y is equal to x. So if I graph this, this would be the same graph as y is equal to log of x. Would you agree with that? So let's go and put some numbers here, see what that's going to look like, and then we're actually going to go ahead and graph that log as well. So that would help us to learn some of the properties. So let's take a look at if I let y equal to 0, what would be x? Anyone? So x would be 3 to the power of 0, so anything to the power of 0 is equal to 1. So my graph is going to pass us through point x equal to 1, y is equal to 0, which would be this point right there. Right? This would be x equal to 1, y is equal to 0. So as I increase y, if I let y equal to 1, what is x? 3 to the power of 1 is equal to 3, very good. So if x equal to 3, y is equal to 1, so my graph is going to pass us through this point here. So let me move this here. So it would be right there. X equal to 3, y is equal to 1. The graph is going to pass us through this point. Right. And as you can see that as I decrease the value of y, what's going to happen? If y is equal to -1, what is x would be? would be 3 to the power of -1, which is equal to 1/3 now, right? So as to the left of this, if y is equal to -1, which is here, -1, you see x would be equal to 1/3. So you get closer and closer to 0 from this side. So if I graph this, the rough graph of this would be, this gets closer and closer to 0 from this side here, and a little curve here, and it that way. So that would be the graph of y is equal to log of x with the base 3. You notice that I didn't even bother with the log because I convert this into its corresponding exponential. You can always do that. Okay. Now, if you were going to put the numbers into the function with the logarithm, let's take a look at that. See what happens. We should get the same set of numbers, really. So in this case, if I let x equal to 1, if I let x equal to 1, what would be my y? Now, y would be equal to log of 1 with the base 3. Right. What is log of 1 with the base 3 anyway? I know I'm supposed to get 0 here because I already figured that out here, but y is equal to 0. So let's take a look at here. Y is equal to log of 1 with the base 3. Can I replace 1 with something with the base 3? That would be what? 3 to the power of what is equal to 1? 0. So if I replace this 1, if I replace this 1 with 3 to the power of 0, which is the same as 1, that shows me that this whole thing must be equal to 0 then, right? You notice that, if you recall, let's write it down here. If you recall, log of, let's use a different color here. If I recall, log of b to the power of n with the base b. If this base of the logarithm and the base of this exponential is the same, the whole thing would be equal to n. So this is something that you want to remember. If you write this in the exponential using this formula here I showed you up here, you can easily see that why this is true. Okay. So as long as I can make the base of the logarithm here and the base of the exponent the same, the whole thing would be equal to this exponent here. So that's why when I replace 1 with 3 to the power of 0, then it would confirm that log of 3 with the base 3 must be equal to 0 then. Okay, does that make sense so far? And that's the same thing that we obtained here, converting this logarithm into the exponential when x is equal to 1, y is equal to 0. So let's go ahead and examine the next set of numbers, which should all make sense now. If I let x equal to 3, y must be equal to 1, right, according to what we calculated. So let's take a look. Y is equal to log of, so you want to know what log of 3 is with the base 3. Well, that's pretty obvious according to what we just said, right? What is log of 3 with the base 3? It's 1, right? Must be equal to 1 according to this here, right? If the base of the logarithm and the base of the exponent is the same, so the whole thing would be equal to this exponent. That's the same thing we have here. So if I go ahead and place this exponent here must be 1, right? This is 1. So this whole thing must be equal to 1. And that also confirms this scenario. So let's look at one more. If x equal to 1/3, if x equal to 1/3, what is y? Y of log of 1/3 with the base 3. But what is 1/3? Yeah, 1/3 is 3 to the power of minus 1. 3 to the power of minus 1. So again, you see how the base of the logarithm and the base of exponent is the same. So this whole thing must be equal to what? -1, right? And that's exactly what we confirm here when I converted the logarithm into its corresponding exponential. So when you have to graph y is equal to log of x, you can actually convert this to its corresponding exponential using this formula, and don't bother with log at all, and just find 3 points, and you can get a rough graph of your function here. Or remember that log of b with the base b turns out to be equal to this exponent, and then look for the numbers that make the base the same as this exponent. So that's why I purposely picked x equal to 3, because log of 3 with the base 3 must be equal to 1. I picked x equal to 1/3. 1/3 is equal to 3 to the power of minus 1. So log of 3 to the power of minus 1, if the base is 3, must be equal to -1. Log of 1 with the base 3 must be equal to 0. Why? Because 1 is really 3 to the power of 0. So this base and exponents are exactly the same, so this whole thing must be equal to 0. So this is how you would graph the exponential and logarithm.